Ladies and gentlemen, welcome to another video in the series of pattern recognition and machine learning. In this video, we will be covering the topic of the probability theory. It's just a small introduction, no big derivation or anything, just so we have a little recap so we can then later work with probability densities and probability distributions. Let's jump right in. Let's say we have two boxes. We have a box that is red and a box that is blue. And in those boxes, we have apples A and oranges O. And now we're given a probability. So we have P for probability that the box that we are choosing is red, and that's 0.4, and the probability that the box that we're choosing is blue, and that's 0.6. And both of them will become 1 because we have to choose either a red one or a blue one. Now let's talk about the general variables that we can see when we talk about probabilities. So as we just said, we have the x and y. In our case, that was the b. So that's a random variable. That could be, for example, a box, or it could resemble a fruit. And those random variables can take values. That's x takes the xi, and capital Y takes can become a xi. Oh, sorry, xj. And n is the number of trials that we do our experiment. So if we, for example, have those two boxes and we start taking the fruits out of these boxes, we have, of course, first to select the box and then to select a fruit from within that box. And now we have further variables, and we start with nij. And that's the number of trials where x takes xi and y becomes yj. So in our case, for example, we can x say that it's the box, and x1 is that it's blue, and x2 can be that it's red, and y can be our fruit, and it can be either x1 or x2, which is equal to the a for apple or oranges. So y can be either orange or an apple, and x can be a blue or red box. And nij, for example, n11 is that we have a blue box and we take a apple out of the blue box. So that's the number of trials. So that would be example 6. So we took out n trials, and 6 of those, n11, we took out, for example, 10 n equals, we had 10 trials, and n11, so this one and this one, this should be y1 and y2. So n11 was a blue box and a apple, and that was 6 times. CI is the number of trials where x was given a specific value. So x was, for example, either a box, the blue box or the red box, and R is the number of trials where y was in this case either a apple or an orange. So this is not counting what the other variable was. So we're only focusing either on x or on y. And now we come to the topic of the joint probability. So the joint probability is written as P, x equals xi, and y equals yj, and we have this semicolon. And this is defined as the number of times a specific event occurred. So this can be, for example, n11 as we denoted earlier. So box blue and fruit apple, divided by the total number of times that we performed this experiment. And this is only valid if we perform this experiment infinitely many times. So if we perform it only twice, we cannot say that this is the case. We can only say that it's the case when we perform this experiment multiple times. Then we have a probability that x equals xi. So this is the number of cases that the x took a specific value, so xi was a specific value, for example, blue or red. So how many times was the box blue, and we select ci as the number of times that the box was blue, divided by the total number of times that we select the box. And this can, and the ci can also be rewritten as a sum over j that sums up all the nij. So we have those values. We have n11, we have n12, we have n121, sorry, and n22. And if we want to select C1, for example, we only add up n11 and n plus n12. And then we have the C, and the C was that one. It does not care what the other random variable is, in this case y, and only cares about the C. And now we come to the sum rule. Maybe let's highlight it. We come to the sum rule. And this says the same as that one, that we have a probability that x takes the specific variable x, the variable x takes the value xi, and we sum up all over the values that the variable y took. So we again don't care, we sum up over all y's, and at the end we only have this one, so we only get the x in the end. So we, by summing up over all y's, we eliminate them, and we only have the probability of x equals xi. And this is called the marginal probability. Besides the marginal probability, we also have the conditional probability. And the conditional probability is that the probability that y takes yj, given that x is xi. And this can be again factored, can be visualized with a, not visualized, can be rewritten as nij divided by ci, and again with n goes to infinity. So how many times we select how many times a event occurred, and divided by the times that the x took this specific variable that was here, because this one, the ci, is the probability of x equals I. That's what we had right there. And now we come to the product rule. We have the probability that x equals xi and x equals yj. This is the same as nij divided by n. That's what we had. And now we can extend our fracture, but by ci. So we divide nij by ci. That's the probability of x, times x divided the probability of x equals xi, sorry, divided by n. And we get this one, because this one is equal to that one, and this one is equal to this one. So now we know that if we want to have the probability of x equals xi and y equals yj, we only have to know the conditional probability times the marginal probability that we can find with the sum rule. And we can again use the compact notation. So let me highlight it. We have again the sum rule and the product rule. So the sum rule is the probability of x is equal to probability of x and y summed over all y, and the probability x and y is equal to the probability of x given y times the probability of y. And now with this knowledge, we can derive the Bayes theorem. So this is also very important. So at first we have to understand that the probability of x and y is the same as the probability as y and x. So we know that we can rewrite the probability of x and y into the probability of x given y times y. And then we can write the probability of y given x. So these are equal. The probability of y given x as px given y times py. So it's basically just the same as here. And we can rewrite this one the same way we rewrote this one. So this is basically the same way we, like this, the same way we split up this probability. But in this case, you see that the probability of y given x times the probability of x is the probability of x given y times the probability of y. So these two are basically the same thing, but we switch the x and the y's on one side. Now we can divide by p to the px, and we get the actual base theorem. So we get the probability of y given x is the same as the probability of x given y times p of y, py, and the probability px. So this might be a little bit complicated, but this is actually a very, very powerful method of understanding what is going on with the probabilities. So let's say we want to find the probability that our box is blue when we took a fruit that was an apple. For this, we need the probability of the fruit that it's an apple given we choose the blue box is blue, times the probability that the box that we choose the blue box, and divided by the probability of the fruit that the fruit is an apple. And this one is fairly easy to understand. So this is the probability that the fruit is an apple given the blue box. So we can just look at our blue box and we see that we have an apple 1 out of 4 cases. So this is basically a 1 over 4 times the blue box. The blue box was chosen right there, 0.6. So we have times 0.6. And now we just have to find out what the probability of the fruit A is when the probability of an apple, sorry. And that's again where we use the sum rule. So we want to find out that, for example, in this case, the fruit is an apple. So we sum over all the boxes. In our case, we use the probability that it's an apple given some box times the probability of that box. So in our case, we have the probability that it's an apple given, no, that's what we want to find out. You want probability of apple is the probability of apple given the blue box times probability of the blue box plus the probability of an apple given the red box times the probability of the red box. And this can be basically factored in here, and we get to our end result that we have implemented the product rule and the sum rule, and we get this base theorem where we can basically just insert the values that we know, and we get more information later. And the last thing that we have to touch on is the independence of two variables. And we define independence of variables if the probability of x and y is the same one as the probability of x times the probability of y. And of course, the probability of x given y is the same as x because the y does not influence the probability of x. So for example, if we have a 50-50 split of the boxes that we choose and the contents of the boxes are the same, it's irrelevant what box I choose, because in this case, the probability of the fruit given the box is the same as the probability just of the fruit, because the same things are in the boxes, and the probability of choosing the box is also 50%. Right. So this is basically just a broad overview over all the probability theory that we need to understand the basics of machine learning. But building on that one, we will add some probability densities and probability distributions, and then we will be done with all the math that we need to understand what is going on. And then it's just simply a, like you could say, like a massaging of those equations to get them where we want them to be, to understand what is actually going on. I hope you understood what I was trying to tell you, and you can check out the videos on the right or in the description down below. Thank you very much for your attention, and see you next time.